Hello everybody and welcome to your next programming lesson. Today we are going to be talking about a very key concept in C and C++ programming, and that's structures. Structures are, I would say, almost a mandatory in C programming because otherwise you are completely lost in complex projects. As you can see, I have some personal banking data declared. Do not be alarmed about this long integer. I separated it with single quotes. That is a modern C23 syntax for long numbers. I can even add more triple zeros, right? This is just for readability. We can even make him a billionaire, sure. I also created a very simple void function for just logging out this data. How to do this we learned in the last video. All right, as you can see, no data is bigger than 64 bits, so we do not need to use pointers right now. And if I just run this, it is completely correct, right? There is 0, 30, and 1 billion. I might even add ID. Next line is age. And on the next line, there will be balance. If I run this, there we go, perfect. Well, this is nice, but this is my guy 1, right? Guy 1, as we can see, ID 1, ID 2, ID 3. I could probably just copy all of this and create a guy 2, right? And then do log banking data. I'm gonna actually copy this and just change the numbers. 2, 2, 2. I run it, and we have 2 guys. I will make this one a little poorer. I'm gonna give him $500, and I'm gonna make him young, right? Because if he's 19, $500 is pretty good. And we can see that I should probably do just a new line to separate this. Yeah, we can see that it is working. We can print this data, but I really do not like how we have to make 3 separate variables for every single new guy, right? I mean, we have to pass 3 arguments just to log this thing. Do you see how complex this printf function is? That's no good, that's no good. Well, I'm gonna introduce you to a new concept in C, which is called a struct, or a structure. I'm gonna call this structure banking account data. That's probably a very long name, but it's actually not very important how I name it here. And I'm gonna explain in a bit. I'm going to copy all of these types and I'm going to put them here. And I'm gonna do ID. This is age, right? And balance. And now I have a structure that I can actually define. For the simplicity, I'm gonna remove these guys. I'm sorry, guys. I'm erasing your accounts. But I'm gonna declare banking data X, right? But as you can see, the compiler doesn't really like that. Why is that? Well, because C is a very old language, and they haven't figured out how to do classes properly, so you have to say struct banking account data 1. Well, it is what it is, right? How to bypass this? I've already told you about the typedef keyword, right? Where I can say that int is a number. And then I can just use int number as an integer. And if I try to print number as an integer, it's going to work without any problem. As you can see, it printed the 4 out. I don't care about this warning right now because the struct is initialized, right? Well, I can actually say that I'm type defing this whole piece of code to banking info, right? So this is just a very more descriptive name, but I'm gonna use banking info. or even account data or something like that. I don't really care. Some people like to add slash t, or I mean underscore t, for it to be a type. I do not really care. The standard C library uses the underscore t a lot. In most code bases, you will not find that piece. Well, let's initialize the structure, right? Well, we have ID, so I can say ID 1, ID 0. We have age. I will say that the guy is 25, pretty young guy. And I will say that his balance will be $1,000. He's probably doing pretty well for himself, even though $1,000 is not a big chunk of money, but people who are 25 are not very financially responsible yet. That's true, right? Now, let's look at our log banking data. I could obviously call this like this, data1, and then pass individual members into the function. That is done by the dot operator. I put a dot, I pick out ID, I put a dot, I pick out age, and I put a dot, and I pick out balance. This is a completely valid approach. But what if I'm a clumsy programmer and I put balance here and age here, for example? Well, what is going on? Yeah, and age here. Well, as we can see, the guy clearly is not 232. If you're wondering why it's only 232 and not 1,000, that's because I used an 8-bit number for the age, and it got the result was basically 1,000 modulo 255, if I'm not mistaken. Okay, well, that's all good, but I don't like that. I'm going to modify this function, and I'm going to say that we are going to pass in banking info. I'm going to say ac, like account, and I'm going to put account ID, account age, and account balance. Now let's see how that works. Log banking data, and I'm going to put data1, and well, there we go. It worked. Now, from the previous video, we talked about copies, right? And how functions copy data rather than passing it through as reference. This even applies to big data types like a structure. Well, let's count, right? 32 bits plus 8, that's 40 bits, plus 64. That is a lot of bits, that's 94 bits. I'm pretty sure there's even some padding. If we printf the size, oh my god, the size of banking data, banking info, the name is probably not the best, we can see that it's even 16 bytes. That is a lot of bytes to pass as a copy, because it has to create a copy inside a function. That is a lot of space on the stack. Well, we know how to minimize that, right? A pointer is just I don't want to make a mistake. 4 bytes on eight bytes. Sorry, 64 8 by 8 64 bits, right? On 64-bit systems. Well, all right. As you can see, we have error squiggles. We know why they're in the main function, because we had to reference the data to create a pointer from it. But here, once an account is a reference to a struct, we can use either. We can still use the dot operator and dereference this with the star, and we can see that it would work. Or we can use the arrow operator, and this is what all people choose to use rather than dereferencing, because it's a clean syntax. So you can probably see a lot of programmers using this in their C programs, maybe even all of them. And we can see that it completely works. And if I printf, I think it's long unsigned, and I'm gonna printf size of this, which is what we passed in, right? It's only 8. It's only 8 versus size of data. That's 16. And do not be mistaken, C structs in complex projects are, oh my god, they are full, because we even use something called a global context in most programs, where there is a struct that keeps all the data that is shared in between all of the files that do something in the application, and it is very, very bulky. So if you choose between like 500 bytes and 8 bytes, you are always going to choose the 8-byte option, right? So the golden rule, even if the structure has, for example, only an age property, we always use a pointer, okay? Maybe even a const pointer, because right now we are not modifying the data, right? There we go. Well, but what if we do want to modify the data? Well, that's probably the same thing, right? Let's say we want to create a function that add balance, or add to balance, right? It's a void function because we're not returning anything, because as we learned, modifying is always better. There we go. And I will basically say, well, let's take into account the reference, the variable, and balance, and I'm going to add a value. I'm going to choose a 64-bit value, and I'm going to say it's going to be called an increment. And I'm going to increment the balance by that value. Let's call the function add to balance. I'm going to choose data1. Also going to have to reference it. And let's make this guy rich, bro. Let's make him rich. Let's add $500,000 into his bank account. If we then log the account again, we can see that he indeed does have $501,000 in his bank account. I'm gonna also do this for future use. This is something we almost always do. Yeah, there we go. Well, this was the most basic usage of a struct ever. I imagine you can think of even more complex ways to use this, and believe me, if you program in C, you will use structs every single day. So keep this in mind. Always use pointers with structs. It's almost never worth it to just copy them. Maybe it's worth copying them if you don't want to initialize a new one in the local function. But I honestly couldn't tell you a reason or like an instance where I wouldn't use them. So okay, thank you for watching this video. If you have any questions, please leave them in the comments, and I will be looking forward to seeing you in the next video, where we will be looking at the dynamic memory in C and arrays and strings. All right, thank you. Bye.